Live from Montreal. It's Tuesday afternoon. Let's go. Oh, yeah, 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 yeah. Come on, come on. Welcome, we're gonna welcome you to the stream today. Oh yeah, we're gonna welcome you. Oh, tell me if you hear me. Welcome, we're gonna welcome you today. Oh yeah, welcome you. Gonna welcome you. Tell me if you hear me. Welcome you. We're gonna welcome you. Gonna welcome you today. Oh yeah, welcome you. Welcome you. Tell me if you hear me. Welcome you. We're gonna welcome you. Hey, can you hear me on the stream? Tell me where you're from on the stream. Oh yeah, see what we got today? We got A.A. Bowser here. We got Alice, we got Nathan and Zach, and let's see where you're from. You're from Norway. Hello from New Zealand. Hey, Tim immediately kills the food conversation. Sorry, I didn't mean to do that. Nathan is from Bangalore. We got We Heart Trains from Northern Virginia and Ann Smith from California. We got Daniela Guerrero from Chile. Sean Ale from St. Louis. Hey, Zach Guess is from California. Top Guess is from Finland. Oh, France and Germany. We got people from where am I? I don't know, Korean Dreamer. You should tell me where are you, because I don't know anymore. I can't remember all of the locations. It doesn't really make a difference most of the time. We're all stuck inside on the stream, and anyway, we got another day here. Oh, let's see. Peter Nuttall is from Australia, Haryana, India. We got the Netherlands. Hey, from Bacon. Is Bacon a place? I don't understand. Hi, from St. Petersburg. Hello, Washington. Today, guys, we got a very special thing going on. We're gonna raise a glass. If I encourage you, if you're of legal drinking age in your own country, and if you in fact enjoy the taste of something, or if you can just grab a soft drink or whatever, hot cocoa tea. We're gonna sit down. We're gonna have a drink with a good friend of the stream. Everybody, welcome to the stream. If this works, it's John Perry, everyone. Hey.
Hello. Hello.
Welcome to the stream. Hear me. Welcome you. We're gonna welcome you. Gonna welcome to the stream today. Oh yeah. Welcome you. Welcome to the stream. Hey. All right. As you can see, hi John. How's it going?
Good to be here. Good to be here.
Good to be here. Can everyone hear John? Is that okay?
Yeah.
All right. I tested the audio beforehand. We should begin. So, hi.
Hi. It's been a while.
It has.
This is your new streaming channel, right?
This is it. Yeah. We're on ACS Live now. 300 subscribers almost. We're gonna
Sweet.
We're gonna break that sub barrier. I think I'm gonna lose a bit of revenue for a while because I don't think this channel has monetization on. I'm not entirely sure about that, but I think whatever.
It takes a while.
Yeah.
I think you have to have 1,000 subscribers before you can apply for it. Something like that.
Yeah. Someone's saying, Tim, turn your volume up. John is louder than Tim. Really?
Uh-oh.
All right. Hello. I don't know if I can get my box is peaking here. It's
Maybe I need
maxed
to turn
out
mine down.
in most places. Hold on. I can bring it up there. There. Now that's that. I mean, I hope I'm not peaking in that audio now, but should be okay. Okay.
Cool.
Yeah, because you're definitely quite a bit softer to me, so I'm gonna have to adjust my levels here. There. Cool. We're here day drinking.
Yes.
Cheers, John. What are you drinking?
Cheers. I got a margarita here. I made my first margarita last Saturday, missing Mexico.
Oh.
And I'm trying it again here. We'll see.
Okay. Have you sampled this one yet?
No, I have not.
All right.
Ooh, and that's strong. I ran low on limes, and so I put lemons in there instead.
What's a margarita? What's in it? Like, I've never made one, and I think I've tried one.
It's limes, it's tequila, and it's orange liqueur, and that's it.
Orange liqueur.
Yes. And it's just like 1 part lime, 1 part tequila, 1 part. I didn't put that much alcohol in this one because this is a fairly large glass.
That is, yeah. That I mean, not
Yeah.
much for the size of the drink. I would say is probably a good choice
Right.
for that.
But yeah, a little lemony today.
All right, cool. Well, this is a martini. I have a bartending friend who was nice enough to give me gin and vermouth for my birthday. He's like, here. He
Nice.
came with a bottle to make martinis at my birthday, and then he was just like, here, it's yours, keep it. So
Cool.
I put too much vermouth in it, I think, but I kind of like too much vermouth. Like usual
Yeah.
martini is like it's like 5 to 1 or something, and I can't even tell that there's anything other than gin in it. Um,
Yeah.
so
Yeah.
eh. Yeah, people are complaining that my green screen isn't working. Yeah, I didn't have time to make the green screen work, but
It's just
that's
it's a
okay.
green wall. It's
It's
a
green.
beautiful green wall.
A beautiful green wrinkly wall. Yeah, you guys get to see what I actually look like in here. It's much less
Nice.
impressive. I don't know. What have you like? The last thing that I saw from you was a picture. The picture you sent of waiting outside the SAQ.
Yeah. Yeah,
So
I
I got
call it
this
the
idea.
Canadian bread line.
The
There's
Canadian
a
Red Line.
there's a huge line outside the liquor store on Saturday because finally it opened up so we could have parties of 10, right?
Okay.
And so I'm going to
Wait,
hang out with.
was that an opening? Because I thought that was like technically a reducing of the previous rules. Like you still gotta like can you have parties of 10 in your house? Because I thought we could only like have parties of 10 in open spaces.
Yeah,
Like
yeah, it's
previously we
open
could,
spaces.
but you still have to like be separated by 2 meters or whatever.
Yeah, yeah. So I don't know. For some reason they told me that it was new.
Mm,
Maybe it was that Marilyn's mom was done being in actual quarantine from possibly being exposed. Maybe
goodness.
that's what it was.
Okay.
For whatever reason, we just had to have a barbecue, and so I had to go get some liquor, and it was like a 45-minute wait in the line, and it's wrapped all the way around the building. So yeah, I call it the Canadian bread line.
Well, the lines get long fast when everyone's like, because like, I feel like with how they demarcate lines, at least around here, they're like with X, where they're like X's on the ground or whatever.
No.
Because like often they're, but the way they put them pretty far apart, they're like 3 or 4 meters
Yeah.
apart. So you'll have these lines, and there's like a limited amount of people who are allowed inside the grocery store at any given time or whatever.
Right.
So you have these lines just stretching down the block, and they're only like 10 people.
Yeah.
It
Oh.
goes real far, anyways.
I was late. I had to wait for a long time. I was late, but it turned out fine.
It turned out
It was
fine.
it was a good barbecue. Yeah.
You got sufficient alcohol to satisfy your friends and relatives.
Yes. Yeah. Everybody was happy.
All right.
Yeah. Classic barbecue.
Weird. Yeah.
Yeah.
It's like the process of things slowly turning back on is in some senses weirder than them being totally closed to me.
Yeah.
I don't
Well,
know.
I mean, Marilyn and I are still going out hiking. We went hiking this morning.
I mean, hiking is
going
great.
out. We're going out into the woods all the time,
Yeah.
and it's super easy to socially distance out there. And at the barbecue, we were just, you're sitting around a big table, so it was fine.
Yeah. You just have to distance from the squirrels. They,
Yeah.
they can be nasty. Yeah. I don't know. I should take this stream on like a proper hike sometime. Do you know if Mount Royal gets cell reception everywhere?
I do not know. I have not actually played around up there.
Yeah, because Montreal is centered around a mountain. It's an island with a mountain in the middle, and there's a really cool like route of like you can just like go into the woods and kind of like scrabble up cliffs and stuff. And I recently discovered when I was shooting the quarantine video because I shot it on an iPhone.
Yeah.
And I was like, okay, I've got to figure out some way to like jerry rig this iPhone to a tripod and to like a snaky sort of thing so I can like put it in because I was like filming in like a bathtub and like a whole bunch of weird
Yeah.
situations.
Yeah.
So I found all this old rigging that I got with an old GoPro that I got at one point. And so I like jerry rigged like I took apart a selfie stick and like attached some like GoPro connections to connect it to my a tripod. And now I'm like, I could attach my cell phone to my head potentially with like this GoPro equipment. And then
That'd be awesome.
let's see like, do a stream hike. I don't know. To see if I can get it to work.
it's an idea, but
Yeah, that would be cool. So I'm on the South Shore, so I
Yeah.
haven't even gone into Montreal since everything shut down. I haven't gone into the proper city.
Okay, yeah.
Maybe once. But I've been we go all over the place out here.
Yeah.
Mount Hillary is where we went this morning.
Mount Hillary, that's Mont Saint-Hilaire in French.
Yeah.
Is that right? Yeah. That's pretty far from you.
Yeah.
That's like an hour drive or something like that.
No, it's like 25 minutes.
Really?
Yeah.
Okay. I guess I'm thinking about, because I don't think I've been to that mountain. That's a beautiful mountain.
Yeah, it's really cool.
And the mountains in Montreal are really cool because it's just like there's nothing around them. It's like flat plains and then a hill, like this lump of a mountain and then more flat plains. So you get like really good views that just go forever. But I don't think I've been to that mountain since I lived in like my parents' house. So it's a longer drive
it's
from
pretty
there.
weird. We've been kind of looking for a house out there,
Mm.
but now it's probably the housing market's going to crash. So
you're waiting for that?
Yeah.
All right.
We're like,
Oh, good. Okay. What are the markers? I gotta figure this out too. I mean, I could pick up a house.
well, yeah, it's expected to drop at least 10% within the next year because of the shutdown. So
Right.
we'll see. I mean, I might even go lower than that, but yeah, we were looking really hard before this, and then we're like, let's kind of put the brakes on. We found a really cool house out by Mount Hillary,
Okay.
but it was a little bit too expensive, and it had a pool. I don't want to have to keep up a pool. Had a really nice pool, like, but I feel guilty for not keeping up.
That's weird. It's like, oh, it had a pool. Damn it! I can't have a pool in my life. That is a negative.
No. I've had pools before, and I hate taking care of a swimming pool. I know that I never use them, and so I'd have to just like drain it. I don't know. Maybe I could turn it into a skate park or something.
Yeah, that'd be great.
Yeah.
Lords of Dogtown or whatever that movie was.
Yeah.
Or we could. I mean, is it one of those pools with like it's like got the curved bottom on it?
It's not very good. You'd have to modify it to make it
Okay.
really good for skating in. But it is big enough. It's definitely big enough to turn into a skate bowl. Yeah.
Because I would love to have a large place to do fluid dynamics simulations.
Yeah.
Pool sounds like potentially good. I would really like to. My honors thesis for my undergrad was to design this like weird contraption that could use the duality between fluid dynamics and gravity to simulate an expanding universe. And
really?
I came up with this weird thing. It was like a downwardly parabolic like air hockey table type thing that like shot water out at every point, because you've got to get something that like water is sort of the analog of space in the simulation, and you've got to get space appearing at every point like it does in inflation. So there was like water coming out and all these things, and then like running out in this like, I don't know, exponential expansion out from the center. And I've always wanted to build it. Like the design criteria are very strict. It has to be about 10 meters in diameter to make it work.
Yeah, this pool's not that big.
It doesn't have to be 10, but it has to be like a fairly sizable.
Yeah.
And I don't think I like simulated it and it worked, and I was like, all right, I'm never gonna get to build this, but I've always wanted to like build it and make a YouTube video out of it. Here's my
that'd be awesome.
project.
Does that have to be circular, or could it be any weird shape?
Well, circular is best, right? I would like to have the whole circular event horizon. Like I actually, the simulation that I ran, I couldn't do 2D fluid sims because we just didn't have a good enough, like strong enough power for our computers. So I just ran like a slice. It was just like a parabolic slice. So you could do something like that, like a sluice that just looks like this, and the water runs off both sides. Because the way you get an event horizon in fluid dynamics is you have to get the water flowing faster than the waves propagate. And then it's exactly like you know, there's a point where the speed of light can't, which is the speed of the waves. Like they just all redshift away to nothing or whatever.
Okay, yeah, that makes sense. Yeah.
Yeah, I don't know.
That's cool.
Yeah. So
Well-
here's me putting my physics designs on your totally not purchased pool that probably
Yeah.
isn't suitable for it anyways.
I would probably cover it up with a deck.
All right. That's probably more practical.
I mean,
Just
I
cover
do
it up.
swim, but I like to swim in like rivers and stuff. So
Mm.
it just we had a pool growing up, and it just turned into a mosquito haven.
Mm.
And then we put fish in there. So we had this giant pool in our backyard full of goldfish and brown sludge.
Oh, lovely.
And so,
But
yeah, I know that's kind of
I mean,
how
aren't-
it would happen.
aren't there hasn't like robotics advanced far enough? Like we're on like the 6th or 7th generation of Roombas. Surely there's something that cleans your pool.
Maybe. But and then, well, we had a chlorine pool. I guess you can do saltwater now, but that's more popular now. But yeah,
Is
also,
saltwater easier to take care of?
well, you have to wash chlorine off of you after you get out. So if
You gotta wash salt off you too.
yeah, like, no, I go swim in the ocean and call that my shower when I'm in Ecuador. That works.
Let's see. Biophile says we use a robot for our pool. Okay, they do exist.
Nice.
We
Nice.
gotta figure out. Biophile, tell us more, please. Design an ROV to clean out the pools. Yeah, right.
Yeah.
Like, I mean, there's so many autonomous vehicles now. Surely this is a $1 billion idea.
Right.
If
right.
no one, but clearly it already exists. If Biophile's doing it.
Maybe you could get one so that you don't have to put any chemicals in there. You just have water and a robot.
Water. I mean, you need something to kill the bacteria. So you're gonna
Well,
need
you
a
get-
water and killer nanobots in your pool, and that sounds like maybe a bad time.
Maybe they use ultraviolet radiation or something when you're not in there.
Okay, sure.
Really high levels. I don't know.
Sure. Yeah.
Uh,
Just throw a bunch of hydroxychloroquine in there. It kills everything.
Oh boy.
I'm sorry.
Yeah.
I'm sorry. How's the conspiracy theories?
I've been
Are
ignoring
you
them.
still keeping up on them, or are you done with that?
No, well, I've been ignoring them. I've been pretty much ignoring all of that stuff. But we
That's
started
good.
reading a book about the Black Plague,
Okay.
and that's been super interesting because it's just nice to know that this is not like something unique to modern society. That
Yeah.
people are idiots always and believing in crazy stuff always. But I mean, the crazy thing about the Black Plague, well, a couple of things I didn't realize is that when we talk about the Black Plague, we're not talking about one event. We're talking about an event that kept happening for 300 years.
Yeah, there were
Throughout
like waves
Europe.
of plague.
Yeah.
that just come
It's
back.
insane. So everyone was just horrified all the time and
Mm.
waiting to die of the Black Plague. It was just
Yeah.
constantly there. And so there's all these precursors, like signs that the Black Plague is going to happen. One of them
Mm.
is if you see children playing on the playground and they start to mimic a funeral,
Okay.
that's going to bring the plague.
Jeez, those children got a lot
Another-
of power.
Yeah. Another one was like pretty much anything weird in the sky. So if you have an asteroid shower, if you have a comet come by, that's definitely going to cause it. Definitely going to cause it. And these are things that the universities were saying.
Wow.
So they're saying that the comets dry up the air and cause the plague to form.
Because the plague is caused by dry air.
There's these people. Dry air, yeah.
Okay.
Yeah, well, miasma theory was,
Hmm.
is based on there's bad air and that's what causes things. So anything that would cause bad air is going to cause the plague.
Hmm.
Then you had these people who, there's just this guy claiming that he saw a bunch of people reaping wheat, and they were in hoods, and they would cut the wheat, but the wheat wouldn't fall. And
Okay.
then the next day, however many pieces of wheat they cut, that's how many people would die in the city.
Ooh.
Uh,
Who were
and
these
that's-
dudes reaping wheat? Just
they were just ghosts, and that's what
Okay.
gave rise to the idea of the Grim Reaper, according to
Oh.
this book.
okay.
I mean, it's hard to pinpoint
Yeah.
the actual origin of the Grim Reaper, but this is one of the earliest things that people were saying that was similar to it,
Yeah.
and so I thought that was interesting. But
Yeah.
just and then all the Christian world thought that this was a curse from God, and so you would, there were the what they call them, so the flagellates. They would go through the city and whip themselves,
Okay.
and
Yeah.
they were atoning for the sins of the people to take away the sin so God wouldn't have to punish them with the plague.
Mm.
And that would have been just such a powerful thing to see, because these people are whipping themselves till they bleed in a big parade, and you think they're saving you.
Right.
And
trying to stave off this plague. And then
yeah, it's so. And then of course there's people who are blaming the Jews, people are blaming all sorts of immigrants. They're blaming everybody. It's exactly like it is today. It's just chaos. But they were in much more of an information vacuum than we are. I mean, we know that a virus is a pathogen.
yeah, they sort
unless
of
you-
like the fact that even the universities were like trotting out these like theories that now seem crazy. Like it was
yeah,
it was the Middle Ages. They didn't
right.
really have much to go on, did they?
Yeah. Yeah, and it turns
I know.
out that it was a bacteria carried by fleas.
Like what had they figured out? Like Biophile is saying that people had kind of figured out contagion, sort of.
Yes.
Like they had those plague hoods, right? They had some sense that like working with plague
Yeah.
victims was likely to give you the plague.
Yeah, my asthma theory was this idea that the plague was caused by bad air,
Yeah.
and that was pretty close. I mean,
Right.
know-
And it was like the idea, but also that the plague kind of generated bad air as well as causing it,
yeah, I mean,
as
so
well as being caused by it.
they were trying to protect themselves from bad smells.
Okay.
And if you're protecting yourself from bad smells, you're doing good to stop the spread of a respiratory infection.
Mm.
There are versions of the plague that could be spread through coughs and stuff.
Yeah.
It's a bacteria that's mainly carried in fleas, but it can actually get it into the respiratory system, and so it can cause infections that way. And when it does, it would spread really fast. So people who believed in my asthma theory, and they would cover their faces and stuff, that was actually a really good idea. That actually worked.
Okay.
So you're getting it's kind of like you ever see the Skinner box where he puts like a pigeon in a box and he gives it food randomly, but he gives it a bunch of things to mess with in there. And
right.
it will develop a superstition and think that it has to peck this one thing 3 times and spin around in a circle twice, and then it gets fed.
Okay. Yeah.
That's what you saw with all of Europe, that people were just trying everything.
And then whatever happened to happen before the plague, they were like, oh, that's what causes the plague.
Yeah,
And
that's now a
yeah.
sign. So
Okay,
I saw
yeah.
some kids doing a funeral, playing at a funeral, and then the plague hit.
Right.
Well, that's now a sign, and so you forbid anyone from playing, pretend funeral.
Yeah.
You think it's from sins, and there's enough different sins in the Bible that you could say that anybody's sinning at any time, so you can
Mhm.
blame anybody.
Yeah.
If anybody does a sin that's public and gets known, they can then be blamed for causing the plague. So
Yeah.
it's pretty wild.
Yeah, and from like a evolutionary behavioral standpoint, it kind of makes sense that you would, like a pigeon would be wired like that,
Yeah.
because when it's random, there's no harm in having superstitions because they're not really
Right.
going to hurt you. They might take a little bit of energy cost, but usually things aren't random, and it's the same system for like that's how a rat or a pigeon learns anything, is they do a thing and something good happens, and it's like, oh,
Yeah.
okay, better do that again. And it only fails in terms of randomness, but it only slightly fails. It fails in terms of some sort of opportunity cost of like could have been doing something else, but you can't really
Yeah.
do anything about randomness, right?
Yeah.
Like,
And then, of course, I think this is really natural. It's instinctual, is to be horrified by someone who's sick and not want them to be in public.
Mm.
So
yeah,
you would get these quarantines that were sometimes the entire city would go under quarantine. Sometimes it would just be the sick people that would go into quarantine, and they get locked in their houses and they get locked with their families. So everybody died, and it spreading it to each other and dying together. But in this case, so when you had a pulmonary version of the plague, that was actually really useful. But when you had when the problem was rats, it was
so there are some versions of plague that spread respiratory, but others don't.
yeah. This bacteria could get into your lungs and then start to spread that way.
Okay.
And yeah, when that would happen, quarantines were actually really useful. But if its main vector was rats, if the rats were really good carriers of this,
Yeah.
then it doesn't matter what you do. If you still have rats everywhere, if the rats are going from house to house and scavenging for food, you're screwed. So everybody could be locked in their house, and the plague just, I mean, it would get 60% of a city, like
Yeah.
sometimes even more. And then people die of starvation. It was insane. I mean, like our quarantine is a cakewalk.
Yeah.
It's been super morbid reading this stuff and sort of like dark, but also relieving in some ways. Like we're just dealing with COVID-19. Thank goodness.
Yeah.
Like,
No, we are.
I mean, obviously, to anyone who's dying of COVID-19, that's no consolation. But it's as a society, this is a lot easier to deal with than what we had to deal with before. So, yeah, it's been really interesting. There's just horrible stories of like there's a kid found in the street suckling from a goat because he's orphaned.
Jeez.
Like it's just the mass. Like, they were just counting the dead, not naming them because people didn't even. Someone would die and nobody knew him because the people he knew had already died.
Yeah.
So it just you get to this crazy spot in the pandemic or the epidemics, I guess is what you'd call them there, where you just absolute chaos.
Primer's new video on like endemic diseases is the first one that I've seen that sort of explained to me how recurring waves like that happen.
Yeah.
I hadn't really realized like how that like I guess over like it's over generational time, right? Like a whole generation gets this thing and then everyone's immune, but then you keep having more kids or whatever, or people come from different places in the country that weren't exposed or whatever, and like your R naught slowly creeps up and creeps up and creeps up towards 1, and as long as it's below, then it's still like the plague's still dying out every time it hits. But as soon as it crosses that threshold of like now there's more than one susceptible person contacting every other person, then it's like whoosh, half your population gets it again. It's like it doesn't settle down to a low sustained level. It has these like periods of nothing and then these huge waves and dying down again.
Yeah, and his model shows recovery, like right.
Yeah.
That's the main thing. And with the Black Plague, it's death basically is what's causing the thing to go stagnant.
But how did the plague die out? Was it just that it killed so many people that people didn't interact with each other, or were there a certain amount of people who did get it and recovered?
So, and a lot of times it would just whittle down the population until everyone had either fled or died, and then they start to regroup afterwards. But there's a percentage of the population that's always just not affected by it. So they just don't get it. And because something about this bacteria, their immune system, the way they mix together, it never causes a disease.
Okay. They're like immune without ever really getting it.
Yeah. And there's a really strong signal of selection in Europe. If you look at populations, so I think it was a study on the gypsy populations. You'd have one population that's all pretty well genetically mixed, and then one group that because they were the way that their lifestyle was back then, they would move a lot.
Okay.
And spread around into different communities, and you'd see the ones that got hit by the plague, and the ones that did not get hit by the plague. And we can actually still see this today in different populations. We can see the genetic markers that were selected for by the Black Plague. So what's
the magnitude of the selection effect? Is it like everyone has this now? It's just like all the people who survived were the ones that have this marker, or is it like percentages?
It was like 80% of the relatives of the people that had gone through the plague had this marker.
Man.
Whereas in the rest of the population, it was something like 15% or something. I mean, it's been a year or so since I looked at the paper, but it's really dramatic.
But it's really just here's who survived. They were the ones with this particular mutation.
Yeah.
Nobody else.
This mutation for some reason, and I don't think we even know. The paper that I read didn't give an explanation as to the mechanism. It was just an insanely strong correlation between this genetic variation and surviving the plague.
That feels like something that we should have a lot of interest in what that particular mutation is doing, I would think.
Yeah, well, I mean, it's it's going to be different for each disease, right? So if you have,
Well, maybe. I mean, it depends what it is.
well, right now, so this virus, we talk a lot about the ACE2 receptor.
Yeah.
It gets in through the ACE2 receptor. Well, if you have a mutated ACE2 receptor, this virus might just not be able to attach to you very well. So if you have an abnormal ACE2 receptor, that the gene is mutated in you, it's just going to make it so that the virus doesn't stick to it very well.
Yeah.
And it doesn't break into you and it doesn't cause a disease. And so there's going to be, I don't think we're going to notice a selection event from this.
Not really, especially since it targets predominantly people who are past like childbearing age.
Yeah. And it's just the percentage of deaths isn't really high enough to I mean, we're talking with the Black Plague, it can be 60 to 80%. So I don't think it's going to leave a super obvious mark, but it might. I mean, there might be.
Well, it would if it became endemic over evolutionary time, it would have a slow push.
Only if it's endemic and it stays fatal. So normally once a disease becomes really settled in a population, a respiratory infection, it becomes less and less fatal as time goes. It evolves to be more and more benign.
Right.
So yeah, I don't know that we would actually evolve and adapt to it that way, aside from our adaptive immune system, just developing the antibodies, and then of course if we have a vaccine. But the other interesting thing about the plague is that it could just circulate in rat populations, and it can circulate in squirrel populations. So we had a two hits of the Black Plague in California in like in 1900 to 1904 was the first one. And then again, we got another one because the governor of California lied about it, didn't tell anyone about it, tried to stomp it out quietly, and denied it because he didn't want quarantine to screw up the commerce there.
Hey, what were you saying about history of having been the same?
Yeah, it's really interesting. And he denied it for 2 years. He successfully denied that it existed. It was just smashing through San Francisco. And it ended up getting out of the human population and into the ground squirrel population there. And because of that, they had a second hit like 8 years later. So it actually stayed alive in ground squirrels. And I don't know if it was causing disease in them, but it was spreading through their population, and then it made it back into humans. So it's interesting.
Is plague is it like cholera, like in that there are now strains of the plague that circulate and we don't mind them, and like it's just when a new one pops up from animals that it's a problem? Or
that's a good question. I don't know. I haven't heard of a benign bubonic plague.
Yeah.
But maybe there are.
Too fast.
Yeah.
No. Zach S is saying people with pneumonic plague symptom cluster is 100% fatal, regardless of treatment. Jeez.
Yeah, that's the one pneumonic. So it's spreading in the lungs.
Jeez.
It's just insane. It just, like, you read those stories and all hope is lost after a certain period of time. Everyone just like, you have people that
everyone just runs away.
Yeah. Some people run away, and then everyone's trying to kill them so they don't come into their city and bring it.
Wow.
Or, not necessarily killing them, but they're blocking them from getting into other cities. But then it's interesting to see the attitudes of people. Some people become super pious because they're begging God for mercy. Other people just say, screw it. We're going to just have orgies in the street.
Eat, drink, and be merry, for tomorrow we die.
Yeah. And it's just like, it's interesting that it kind of pushes you either way. There's not very many people that are just like kind of in the middle,
Yeah, well, does it make sense to be in the middle? Like, I'm gonna go to my day job and plan for my 20-year retirement in the middle of the plague. Or whatever the equivalent was when people were serfs, whatever they were doing.
And they say that the Black Plague kicked off humanism because it destroyed the illusion of some people being highborn and others being lowly and having to stay there. We realized that, oh no, everyone's screwed by this. And servants would rebel against their masters when they're the plague breaks out, because what am I going to do? Make your dinner while my family's dying and while I might be dying? No, I'm just going to steal all this food that I know way more about all this, the stuff in your house and in your kitchen than you do. And I'm just going to take this and I'm leaving. And so you'd have, there were noblemen that would just starve to death in their house.
Because the servants, it was like a vector for serf rebellion.
Yeah. Yeah. And then huge economic booms afterwards, because there was tons of stuff and not very many people to use it. So tons of land, tons of like houses and buildings. And so people, and lots of gold that was just left, money that was just left. The money, of course, becomes less valuable when there's more money than there are goods and services. Money loses its value. But there was all this land, and a lot of the people who survived it were the people who were working the land in the first place. So they would go retreat into open spaces, and then they would come back, and there's mansions are hanging out, and there's fields that they can take over. So it was super interesting.
Is this like we're having a hashtag Thanos was right moment here?
Well, well, it's because there was a bunch of people being productive before the plague, and then everybody got to coast off that pre-plague productivity that allowed this boom of wealth. It's
like everyone produced a whole bunch of stuff, and then most of the people died, and everybody who was left got to take all the stuff.
Yep.
Right.
Yep.
All right.
Yeah.
Yeah.
It's just like if there was a zombie
sense.
apocalypse and just you and your 10 friends survived, you've got any car you want.
Yeah.
But
especially
come
if the
back in
zombies
100 years.
Somehow the zombies are gone now.
Yeah. Magically.
feels like a useful requirement. Wow, this conversation took you think about dark things sometimes.
Well,
I guess it's kind of like it's in the game of like evolution only works when there is death, like, or at least there's only really evolution when there's death. So I guess you spend a lot of time thinking about death in various ways.
You don't have to have death. This is actually a really common misconception, because
oh no, yeah, you can have
failure to reproduce.
Yeah,
that's death actually doesn't matter at all. It's failure to reproduce causes it's a differential in reproductive success that causes evolutionary change. But
and then death just happens to be one of those things that keeps you from reproducing.
Yeah, super easy way to stop someone from reproducing, or have an animal not reproduce, is to have that animal die before it reproduces. So
almost surefire, I would say. I'm sure there are exceptions. Probably there are exceptions with plants and stuff. I don't know.
Yeah. So I've got physics questions for you.
Yeah, we want to do physics questions.
This.
Okay, cool.
I am working right now on. I'm in the pre-planning stage of a video series on genetic information. What is genetic information specifically, and also the origin of genetic code.
Tackle this code question that keeps popping up in the atheist discourses.
Yeah. So for those who don't know, a lot of atheists say that the genetic code is not real code. And they're saying that in response to Christians who are saying that you can't get code without a coder.
Yeah.
And so
it's a defensive strategy that happens to, it seems very definitionally dubious. It's like if you make a very specific definition of code such that codes require a coder, then the genetic code is not a code.
Yeah.
But it's mostly an argument about language.
But there's also a very interesting thing about the word information. People seem to think that information is somehow magical or not natural. So I have information in my head, right? I can think about stuff, and it seems like that's not a physical process, but it is a physical process. Information really is, information processing it's happening in a physical substrate. You've got neurons that are reacting with each other and so on. That's causing this to happen. And I've kind of gone down the rabbit hole of information, and I keep finding physicists say that the universe is made of information.
This is
And I'm wanting to get your take on. are they just rephrasing something in a way that sounds weird? Or is this a really important thing to think about? Do we need to be thinking about the universe as an information processing system? So
I think it depends on the physicist what exactly they mean by that. Like there are physicists who really like who really take a hard line of like there is like really at the end of the day it's going to be this it from bit thing where nothing is anything but information.
Yeah. Yeah.
And then like I don't know, I mean give me 10 physicists and ask me what they mean by, ask them what they mean by the universe is made out of information. They'll probably have different answers for you. Let's see, what can I tell you? So the way I think about it is that as far as I can tell, the universe has two aspects to it. It has the laws of physics and it has the state on which the laws of physics apply, right?
Yeah.
State of the universe that like, you take a state like this is simplifying in like GR terms, or maybe it's not. I don't know. It depends how time ends up working in the end. In quantum mechanics, usually you just have time. You can treat the world as being slices of like three-dimensional space that like a movie they go forward in time, and it's like in a computer code. You've got a state, and then you've got an equation that says how all that information interacts to evolve it towards the next moment in time or whatever.
Yeah.
Right. So the laws of physics are how you get from one state to the next, but the state itself is what contains all like the information within the system, right?
Yeah.
So I don't know, you have an image, you're going to do some sort of convolution on it. You need to like the convolution algorithm is not going to do anything to a blank file. You need a file with some bits in it to do something to, right?
Okay. Well, let me pause right here. Just you say that when we say that matter contains information,
I mean, information is like matter containing information or matter being information.
right?
I mean, you can do a lot by wiggling your definitions around, but like there is a state with some amount of complexity that you have to describe. There's an atom here but not an atom there. What are you gonna call the fact that there's an atom here and not an atom there, right?
So this is how I've been thinking about like a truck driving down the street, a bus traveling down the street. It contains information about itself, about its mass, about its velocity, about these things. And if I get hit by that bus, that information is transferred into my body instantly, right?
Yeah, a particular part of the information, mostly the overall momentum of the bus.
And
is what will be transferred to you. But
that's the front of the
bus.
That's
a type of information about the bus, yeah.
Yeah. And then that is direct information transfer. You could say that the universe has done a calculation.
Yeah.
And that's going to be and there's no lying. You can't there's no misinformation there. Like all of the information about that bus, and it's
physical as far as I know, there's no concept of misinformation in physics, but
right.
You're wrong. Yeah.
Right. So there's no lying, there's no funny business. Like the information is going to be transferred into my body. Like that bus is,
Well, it's more I mean, information being transferred. I'm not like you are also a big bag. You could think of yourself as a big bag of information, and the truck is a big bag of information. That are they're both part of a larger system. And
we're about to get entangled. Right?
Yeah, basically, right? It's like if you put two numbers into a hash function and they spit out a third number, right? Or maybe they spit out two more numbers, right? And then you duplicate that process or whatever. Like you're some sort of hash function of some sort of complicated string of bits, and the truck is some sort of complicated string of bits. You put them into this laws of physics function, and out the end comes the next state of the universe, which is you at time t
He's stuck on the front of a bus,
t plus epsilon, and bus at t plus epsilon, right? So it's like whether the information is like transferred from the bus to you is a weird. It's a little bit of a weird way to phrase it, but it's like
you say a calculation has occurred, right?
Yeah, and when people talk about information conservation, they're talking about a very specific thing about quantum mechanics, which is that quantum mechanics, the way quantum mechanics encodes information is as a vector in a ridiculously large vector space. So how much do you know about vectors and such?
Almost nothing.
Okay, let's do a really simple example. You're a graphic designer. You understand color space, right?
Yeah.
So you like the cube of possible colors on a computer screen, right? There's like a red axis, a blue axis, and a green axis.
Yeah.
So your color is represented by like some point in this cube.
Right.
Right. So similarly, you can have an arbitrary amount of information represented by a single point in an arbitrarily complicated space, right? If you need to encode 100 bits, you have 100 axes, and then you put it somewhere. You put a dot somewhere, and it encodes 100 numbers. So the way that the laws of the Schrodinger equation, which is more general than just like this wave equation for a single particle, the Schrodinger equation is how anything evolves in time given any laws of physics, essentially. The Schrodinger equation says that the evolution of any quantum system is a rotation in that space, which essentially means that your vector stays the same length, and you could always rotate it back, right? Whatever state it starts in, it's going to do some complicated, crazy rotation in like hyperdimensional space. But when it gets to the end point, if you just reverse time, like given the information you have now, you have all the information needed to just reverse it and wind it right back to where it started. So this is what's meant by information conservation, essentially. Is that there's no funny thing where like you collapse down that vector into something that's just like a subspace of the total space that then you can't figure out where you came from initially.
Okay. I understand.
Yeah.
And
so that's what's meant by information conservation. But it's I don't know whether it has some deeper connection to like computer science. Information is kind of to be seen. I think it's like TBD. Like you can, in particular situations like quantum computers, you can make very explicit correlations. But whether the universe is a quantum computer that works on bits or not, unclear.
Okay. Well, so it seems like when we get down to, there's a couple things I want to talk about here. Well, first of all, you said you don't like me saying information transfer when during that there's information transfer in a collision.
But you could say there's okay. Complete your question.
I think I feel like it's important to talk that way because so when we're thinking about the genetic code is the set of rules that govern a communication system that exists between the nucleus, in us, it exists between the nucleus of our cells and the ribosome, which lives out in the cytoplasm. Bacteria, so they don't have a nucleus, but they have it's the genome complex, so the genome and the proteins involved in packaging the genome, and the ribosome. So you have an actual communication system where information from the genome is transmitted. It is encoded into RNA, transmitted to the ribosome, and the ribosome decodes that into protein.
Yeah.
And so this is a classic Shannon communication system. And
what's oh, did I lose you?
What's
a Shannon communication system?
Claude Shannon gave a universal description of what a communication system is. You've got a sender and a receiver. And the point of communication is to get information that the sender has to the receiver, and it needs to be packaged in a way that can be transmitted from the sender to the receiver.
Right.
And it's always transferred through some medium. So it could be transferred through a wire. Right now, if you and I were in the same room, through our voices. So my brain contains information. I am encoding that information into movements of my voice. That is transmitted as a message through vibrations in the air, which your ear picks up and decodes back into those same ideas. So the information is transferred between you and I. But the reason that I like to talk about physical information and how it's different than the type of, because I can lie to you. The bus that's going to hit me can't lie to me. It can't lie to me about how hard it just hit me, right?
Yeah.
I can lie to you. I can give you all sorts of false information, and this ability emerges when you have an encoder and a decoder that are fallible. So, like, I don't have to send out all the information that's in my head to you, and you don't have to decode it perfectly, right?
Mm.
And so those two things allow miscommunication to happen. But so back to the bus example. You've got direct information transfer when you're hit by the bus. There's also a way to do indirect information transfer with the bus. Is that, the bus is driving through this world that's bathed in photons, and I happen to have a detector for photons in my head. I have two of them, my eyes.
Yeah.
And so I can actually pick up just those distortions in the electromagnetic field that the bus is causing, and I can use that to get information about the bus, and I can move out of the way before I get hit. And that is indirect information transfer. And what I mean by that is that the photons are actually interacting directly with the bus, and the photons are interacting directly with my retina.
Yep.
But there's two steps there. And so that's indirect information transfer.
Well, I'm not sure that's
for
any more indirect than the transfer of the momentum from the bus to you. Fundamentally, both the transfer of the bus's momentum to you and the transfer of the bus's color to your eyes are mediated by the exact same electromagnetic force. It's just an exact same electromagnetic field. It's just a question of which type of fluctuation in the field and how close you have to be to receive it. So there's always going to be a medium of transfer between the bus and you, because your electrons interact electrically with its electrons, but electrostatically with its electrons. But I get your point.
Yeah, so
there is kind of, I don't know, there's a hierarchy of rangedness, or kind of, I don't know.
Yeah, so I am still just detecting the bus as it's moving, which I would detect if I just let it hit me, right? My whole body would be a bus detector at that point, instead of just my eyes, my eyes and my brain. But so maybe there's a better way to talk about it, but you have a sensor that can gather that information.
There's a way in which I don't know, for one thing, like the information that you're getting transmitted to you from the bus through like light, you can sort of see it as one way, right? Like the information is coming off of the bus and it's hitting your retinas and you're encoding it in your brain. Whereas any sense in which a bus that hits you is transmitting information into you, you're simultaneously transmitting information into the bus, right? This is equal and opposite reactions. Like a more direct way to transfer information into a garbage truck is to take something and put it in the garbage truck, right? Like then you're really transferring information one way into this thing, and I don't know, making it part of it, whatever your conception is of the object of a garbage truck. But I mean, like, I don't know, I guess it's a single bit of information. Like the interaction that's happening on that level with the bus, it's that the bus has a momentum and you have a momentum, and broadly speaking, you put them into an algorithm that adds puts your masses in and spits out velocities for new momentums, right? So the bus gets a new momentum, which is not very different because it has a large amount of inertia. You get a new momentum that's very different because you have a very small amount of inertia compared to the bus. Not only that,
and my shape changes.
Well, each one of your atoms gets a new. This is happening on an atomic or like a particle level, right? Each one of your particles that make you up gets a new momentum at the instant of or through contact. The ones in the front of your face might be going faster than the ones at the back of your face, so that's going to cause problems and whatever else.
Right.
You have to equalize it out. So,
but well, about this,
but they all have the same amount of information at the end. It's not like the bus lost information and you gained information.
right,
It's that
right.
they all changed, but at the end, you're probably going to have about the same amount.
Yeah, but its velocity was transferred into me more than my velocity was transferred into it.
Well,
So
no, it's just that your velocity was smaller, right? Or like your momentum was smaller. You transferred
yeah.
just as much momentum to the bus as the bus transferred to you. It's just that you're smaller, so you had to carry that momentum in a smaller package, which made you go faster.
Yeah. But when you have a detector like the eye, you've got a detector and it's trying to detect a very minimal type of information. So if I can detect photons, but then it needs to interpret that information for me. I then have to interpret that information.
Yeah.
And I can interpret it wrong. So I might not think the bus is as far away as it actually is, or,
Yeah,
if it's a really small bus, I might think it's far away when it's actually closer.
Yeah, your eye to your brain is not only is it a detector, it's also like it's an interpreter and an amplifier.
Yeah.
Like you've got to take that one signal and decide that photon is really relevant compared to all the thousands of other noise photons that are hitting you at the same time, or the photons that are just as bright but encode for a tree or a bus that isn't moving or whatever. So
Right.
you've got decisions and heuristics that you have to make about which bits of information to amplify and which ones not to.
Yeah.
And that can lead to errors if your heuristics are in error. Whereas getting hit by a bus, there's no processing you have to do. You get all of the information the bus gives you, and that's the end of it, right? You're not discarding anything. You're not amplifying anything.
So in signaling theory and evolution, so there's a whole branch of evolution called signaling theory, and what they're trying to, it was developed to try and understand how communication systems develop naturally.
Okay.
And what they found is that whenever you have two organisms cooperating with each other, they're going to develop a communication system. They're going to evolve one. If they have brains, they might just invent one. If they don't have brains, they will evolve one. If they're cooperating long enough over multiple generations, and it works like this.
Evolve like instinctual understandings of each other's behaviors.
Sort of. So, well, I think a good example that we're all familiar with here in Canada is the red-winged blackbird.
Okay.
It's got that really bright red spot on its wing.
Yeah.
And that's communicating its health to the female, and it doesn't know that that's what it's doing. Like it turns out that the red pigment is super hard to build. They have to have a really diverse diet in order to build that red pigment.
Okay.
We used to have some red-winged blackbirds at the wildlife center. We could never get their wings to be red. They would always be this nasty brown color. We just couldn't do their diets right. I'm sure there's someone who studied this and knows how to do it correctly.
So it's a very particular signal that's evolved to tell you this blackbird is at peak blackbird health. Nothing else will do. Okay.
Yeah, it's like if you can have a bright red wing spot, that means that you know how to get bugs and you know how to get fruit and you know how to get all these things.
All right.
And so if the female, so what happens is that they're like, how do these things emerge?
Is it just the males in the red-winged blackbird, or is it?
Yes. Yeah. Okay. The females are brown. They're very camouflaged. So the males have this. Some species I think just have red, but a lot of them have red and yellow on their wing, and then they're super dark black. And so it makes that the black just makes that red pop. It's super bright, and they are under selection pressure because they're attracting females. They're under selection pressure to make that stand out more and more, make that brighter and brighter, and which is why we think they became black, and why because that helps the color, the contrast is better.
Okay.
And the red is what they're actually building with their behavior, is going out and being good red-winged blackbirds and getting lots of good food and being strong and proving that they have good genes. But so there's the female is trying to detect who her best possible mate is, because she's going to have to raise these babies and spend who knows how long raising them. She doesn't want bad genes in them. So what you have is you just have this thing would start out, this communication system would start out with most likely with the female being able to pick up on something about males, that so this female has an obsession with the color yellow. This female just naturally we're born with different little quirks that we find attractive, right?
And some female is born with some obsession that happens to correlate with health.
Yes. And so because she has this obsession,
reproduces a lot because she finds a healthy partner.
Yeah.
Cool.
Yeah, she might not reproduce more than normal, but almost all of her babies survive to reproduce. So
Okay.
so her weird thing with the color red, this weird obsession she has, her red fetish, you know,
Yeah.
there's if all the birds are brown to start out with, and the males that have a little bit of a red tinge, she's into that. Well, it turns out that it's hard to have that red tinge. And so she starts to be really obsessed with that. And then all of her offspring are successful. So now you're getting a bunch of females that are obsessed with this red tinge. And well, it might be really costly to have that red tinge all over your whole body. So some male who evolves a redder tinge on his shoulder and less red everywhere else can actually pique the interest of the female more than normal because he's got this flashy part.
Yeah.
And she's tickled by that. And he's also healthy. And so you get this feedback loop between the male and the female until you get a ridiculously strong signal. And it's super, super clear. But this starts out with, is you have what's called a cue. So in signaling theory, you start out with a cue. A cue is something that another organism or thing is emitting on accident. But there's, when I say on accident, it doesn't totally make sense in the context of evolution. They just happen to be emitting this thing. We're constantly emitting noises. We chew our food. It's loud. I notice I start to like sigh when I sit down and like get up. Like I didn't used to do that when I was younger, but now I'm like, I'm sure that's some sort of cue of my age.
Okay.
It's not something I'm trying to. I'm not trying to give people clues about how old I am, but
it is a cue that you're giving.
Yeah.
Okay.
So we're constantly giving out cues on accident, and a really obvious one of this is when I was a Boy Scout. When I was a kid, we were taught that bears don't want to be startled by us because then they'll have to fight us if they're in close proximity. And bears don't like to fight humans because they don't win very often. And even if they do, sometimes they get hurt pretty badly.
Okay.
Even Boy Scouts apparently can injure a bear. So
hurt a bear. I can believe that. Might not kill the bear, but you'll at least
right.
Yeah.
If you're trying to make a living in the woods, you don't want to have a swollen eye, you know.
Okay.
It doesn't matter if you won the fight. If you got a black eye, you're kind of screwed for a while. So the bear wants to get out of your way. He wants to know you're coming so he can leave. That's kind of the agreement the bears have with humans, black bears in Oregon at least. So what we were taught to do is be extra loud when we're walking through bear regions. So just talk louder. So
this
what
is
we
your
did
cue. I am a human.
Yeah, we realized the bear is picking up on a cue, and we magnified that cue. When we magnify that cue, an evolutionary biologist will tell you that is now a signal.
Okay.
When the sender of a cue benefits from the receiver responding to that cue, and then over evolutionary time, selection starts to favor them magnifying that cue, we say that cue is now a signal. That cue is now officially a signal.
All right.
And this is really interesting because
it's now intentional to the extent that it's like it's designed into the genome in more than a random correlation.
Right.
Okay.
And because we have brains, we can shortcut this. We can just learn what the cues are that someone else is picking up on, and we can then magnify those. But and that's how languages are invented. If you see two foreigners that don't speak the same language try and interact with each other, they'll develop a really simple pidgin language where they end up associating noises and gestures with desires of the other person, and they start being able to cooperate with each other. Right. And so with brains, you can shortcut this. Just you can figure it out. But when you have two evolving entities interacting with each other over a long period of evolutionary time, they actually will develop a communication system as well. And this is what the genetic code is. It's a communication system between, we actually think it's a communication system between different evolving strings of RNA that have developed this communication system between each other. And so what's interesting about this is you have direct information transfer.
You might have to, I don't know, you might have to take me by the hand and walk me through the steps of how that works in the case of RNA, like how this is I don't know how the mapping goes between red-winged blackbirds and the genetic code, because I can see that it's information transfer. I have a little harder time seeing what the mechanism is for one thing to send out a signal, like one RNA strand to set out a signal, and for another one to like have a preference for it in such a way that it would amplify that signal.
It all has to do with evolutionary time. So with evolution. So the reason I gave the red-winged blackbird example is that we have no reason to think that the red-winged blackbird is figuring anything out with its brain.
Right.
With this, they've evolved. The female has an obsession with red, and the male has an obsession with getting good nutrients, which happens to make his red brighter. He doesn't know why his red feathers are so bright. He just knows he was following his crazy encoded instincts that he has to get these different types of food, and that's what caused, he doesn't know it, but that's what caused his wings to turn so red, and that's what caused the female to be so pleased with him. They're just doing this. There's no this entire thing is evolved. What you have with RNA, so are you familiar with ribosome?
Yeah.
Which translates messenger RNA into protein.
Yes. Yeah.
So the ribosome does a lot of complicated things. It's got a chunk of it that clamps onto a messenger RNA. It's actually like there's two units. They clamp onto a messenger RNA together, and they start to read it, and they attract transfer RNAs with specific amino acids on them into the inside of the ribosome. The ribosome then rips the amino acid off the transfer RNA and adds it to the chain of protein that's growing. And the messenger RNA is telling the ribosome what type of transfer RNA to attract, and then it rips off the amino acid that comes with that transfer RNA, and that's how the system works.
So the information goes, RNA has 3 little nucleotides on it that are a signal to the RNA, attract these particular matching nucleotides. Those already
transfer RNA.
Those already have attached to them the proper
amino acid.
Yeah. So you attract the right one, and then you pop your little amino acid off. You add it to the chain. You feed through the next RNA, another 3 nucleotides, another transfer RNA, another little amino acid. Build a chain encoded for by the RNA into a protein that does something.
Right.
Yes.
Right.
Cool.
So where the details on the origin of this system are very unclear. However, what we do know is that the ribosome, the core of the ribosome that actually does the ripping off of the amino acid and the attaching of the amino acid to the growing protein, that part, all of the enzymatic activity there, all the activity is happening purely with RNA. So there's a chunk of the ribosome that's just made out of RNA that's doing that. And they call this the core of the ribosome. And
so the RNA the ribosome is an RNA machine with kind of a protein exoskeleton, or like protein helper bits.
Yeah. So it's a complex between RNA and protein, and it some of the enzymatic parts in the modern ribosome are made of protein, but the core functions are just RNA. RNA is doing all the work. And so it's a chunk of RNA folded up in a specific way so that it has this ability to cause these chemical reactions that can break apart. It can break the amino acid off of the transfer RNA. It can attach it to the growing protein. And what we found is that this core section that does that reaction, we think is the oldest, because it shares the most universal. It's the same in every organism. So we think that part is the oldest, and it needs to stabilize itself with proteins, but it's actually not very particular as to what shapes those proteins come in.
It just needs kind of like a shell around it to keep it safe.
To keep it stable, yeah. And so one of the ideas is that the first thing that existed was this chain of RNA that happened to be able to break amino acids off of peptides in its surrounding and add them to a peptide that was kind of stuck to its own body. And it could do this, and it could grow that peptide and use that to stabilize itself. And
so
that
the first proteins that the ribosome would have produced would have been just sort of globs that would stick around it and help it maintain itself.
Yes, very random. Their structure wasn't that important.
Right.
It was just, it helped it so that it would be more likely to survive in a weird temperature, a weird acidity. It wouldn't break apart. So it's just doing this.
Basically a machine for gathering bits of its surroundings and building a little nest,
sticking them to itself, so it doesn't get hurt by the outside. So it's a molecule that, if you talk to some people, they're saying that it was also capable of reproduction, and that's why it's evolving to get better and better and better. There's one guy who has a very different idea about this, and I don't understand his thinking.
Well, the idea of the whole RNA world wasn't it that all of these little RNA bits had to be capable of reproduction, or at least like were reproducing?
That's the classic view, but there's a new version now that a couple of people at Georgia Tech are looking at that doesn't involve that at all, and I do not understand it. But so it's easiest for me to
sense to me. You can't get more than one copy of a thing if you can't.
He claims that you can,
Right.
and I do not understand. I mean, the reason that I think RNA is so promising is because RNA acts as a template for its own replication. But he's saying you don't even need that, and I'm like, well, why? Okay, why is RNA so special though? So anyway, that aside, I do need to get a hold of him and really try to wrap my head around what his thoughts are, because it does not make sense to me. But
I'm gonna stop you for one moment just to let you know that as viewers of this will be well aware, often my batteries die on my little machine here. My batteries are flashing the low battery light, so if I suddenly go silent, don't worry, I can change to a different signal or in like 10 seconds. Just be aware. I'll probably go like, and then you won't hear anything from me. But yeah, so the main theory though is that the ribosome at one point was reproducing on its own.
Yeah, it was a self-replicating chain of RNA. So it was using some sort of system in its environment to replicate itself. And it was also had this ability to stabilize itself with little proto-proteins that it was building out of stuff it was finding in its environment.
Okay.
So it's doing this. It's building these little proto-proteins, and whenever anything interesting is happening in an environment, other organisms that are in that environment as well might find those interesting and useful and want to exploit them as well.
Sure.
And so if you want to look at the symbiotic route to the origin of the genetic code, using signaling theory, like the red-winged blackbird, is that something could have picked up on the fact that this this structure is building little peptides, and they could have been anything they could do to steal one of those peptides from it, or coax it to build more of them and excrete them so they could use them too.
So our other RNAs become kind of little parasites on their ribosome, taking its proteins.
Some would be very parasitic and nasty. Some might be more benign, and the more parasitic you are, the better chances you have of killing the host, right? So just like with a disease, things are going to evolve to be more benign over time. So you can get actual cooperation to where there's cooperation between different species of RNA. You've got the ribosomal core that's actually building these little microproteins, and you've got a whole group of other RNAs that are helping it do this more efficiently. And eventually, you get some that can guide it so well that it's building very specific proteins that end up folding in a very specific way. And just like you've got this red-winged blackbird who has a really obvious signal now, you start to get really obvious signals that you can actually detect if you were studying this as a scientist, like, oh, this chain of RNA is signaling the ribosome to build this type of three-dimensional protein. So that's the gist of it. And it's, people are not
Hello. Good. Hello, I'm back.
all right, yeah, we're working.
We got it. So people are not, sorry.
So there's not anybody working on this in a way that combines RNA world with signaling theory and with information theory and engineering. And I think that it's people are saying the same things that I just said,
Okay.
but with very different paradigms. And I think that this paradigm it's the most useful for me. Thinking of the genetic code as this communication system, which it definitely is, according to like Claude Shannon's equations, and then using signaling theory from biology to ask, how do communication systems develop? Well, we know how they develop. You have two evolving entities under selection pressure to cooperate, and so they evolved the ability to send signals, and that's what we're seeing in the genome. I mean, that paradigm fits perfectly as to what we're seeing in the genome.
Wow, I had never heard of any of that, and that's yeah. I mean, that makes a lot of sense to me. It's like I don't know. Is it more specific than like sort of the general statement that more information transfer between parts of a complicated system allows more complex, like there's sort of a basic entropy thing where if you have one isolated informational system and another isolated informational system, there's a certain number of configurations that any of them can take. But if you combine them with something that can swap information between them, there's an exponential increase in just the number of configurations that they can both access as a joint system, right? So like the possibility space just becomes incredibly large. You know, if you add one bit to a system, all the different ways that bit can interact with the existing bits is, you know, it's the same as the total size of that system. So you get two systems, it's like a this to the power of this sort of effect of the total possibilities of like combinations. And just that expands your evolutionary landscape so much that like the fittest point in the space must be one where those systems are connected as well as possible.
Yeah.
Right.
And the genetic code the genetic code is just the set of rules that the ribosome uses to transfer RNA into protein, to read RNA and build a protein. So that set of rules would have stabilized out of a much noisier starting point. At first, you're building random proteins. Mm-hmm. So they're random in length, they're random in sequence. And then you start to develop abilities to build them that are specific lengths. And then you can be more specific about the sequence until finally you get the modern code, which is extremely accurate. And I mean, it's really hard for the ribosome to misread a messenger RNA. The modern coding system has redundancies in it so that errors are extremely hard. Yeah. It's super rare for a ribosome to misread a messenger RNA. So there's been a lot of study on that. So people have already been using Shannon information to figure out how efficient the genetic code is and how resistant it is to error. That's been used a lot. But I think combining that with signaling theory really helps make it helps make sense how the origin of this would have occurred in a way that's intuitive. Once you understand signaling theory.
Yeah, and it's a. I'm not super surprised that there aren't that you're, potentially not seeing a lot of stuff about this yet, because it combines a few. It requires a combination of a few perspectives that you have that aren't necessarily universal even within biology, right? Like the view of the even of the, I don't know, a chromosome or something as a symbiosis of little RNAs or whatever. Like I'm not even sure how widespread that view is. I like it.
That is pretty. That's actually pretty
okay.
Widespread, because that's like, if you look at the selfish gene. So Richard Dawkins is probably I think Richard Dawkins is now more famous for being an atheist, but the selfish gene was about the genome being a cluster of symbiotic genes that are they're cooperating with each other within the genome, and they're competing against different versions of themselves in other genomes. So that's where the selfishness comes in. So there's a long history in biology of looking at symbiosis as the origin of complexity.
Okay.
And as the origin of signaling. I mean, the signaling theory is old. It's way older than me. It's been around for a while.
Well, Claude Shannon was what, like 40s, 50s, something like that.
Well, okay, so that's different. So signaling theory in biology is separate from information theory in engineering.
Yeah.
But it shouldn't be. Like I'm one of several people in biology pushing to merge the two, but it requires giving up on vocabulary words, like deciding who wins in certain situations. Right?
So
when things are defined differently. I think that a lot of biologists, if you ask them what information is, they'll be all over the board as to how they would define information.
Information in physics is literally like, it's just anything that codifies something about the physical state of the universe. Like,
but when you get to...
There's a technical definition, like when you're trying to count bits of information, then you have to get more technical with it. But in the broad sense of, like, whether information is lost or gained or whatever, what you're talking about is anything that describes the system, that lets you entirely model the system and do anything you want with it. Any bit of information, any number that's required for that is part of the information of the system, right?
The concept of bits comes from Shannon's work.
Yeah, well, and bits are important if you're in a discretized system, right? But so far, quantum mechanics seems to use continuums. I personally don't really like continuums, but we use them for everything. So like a bit is not necessarily the most applicable thing. A qubit can get you further, but even that, you're like, you've got a discretized set of individual little continua, and but as far as we can tell, space doesn't seem to be discretized, doesn't seem to be made up of bits. It just seems to be who knows what it is.
But that gets really weird when you're trying to think about space. Well, thinking of anything that's continuous is weird. I can't understand infinity or nothing, right? Those two concepts are equally confusing to me. And the same with understanding things as being bits versus continual. It's like both of those things don't, like, if the universe is truly quantized versus the universe is actually continual.
Yeah.
Like, it doesn't, like, neither of those make sense to me. Like
most of the most of the quantization that comes out of quantum mechanics is it's kind of it's not a fundamental quantization of everything. It's a quantization like the quantization of the frequencies that come off of a guitar string, which exists. But it's based on the fact that the guitar string is a continuum that happens to be having waves that can only take specific frequencies and stuff. It's a very different question to ask: is the guitar string itself made up of individual specks that are interacting that you can't cut finer than that?
Is space made of pixels, right?
Yeah. That's a totally different question.
And I've heard people say that space is made of pixels because of what is it? What's the smallest unit of measurement?
The Planck length. I mean, that doesn't say anything about what's going on down there. All the Planck length, the Planck scale is a definite place where no one knows what's happening. That's pretty much it.
But
like, I don't know.
This
could be 30 other levels below the Planck length for all we know. Like, one of the things I like to, I don't know, for some reason I've taken this as a thing that I say on this stream and elsewhere, but like literally for all we know, at the Planck length there could be a lot of little gnomes that are, mining gems in some sort of complex economy, and that's giving rise to our quantum field theory. Like, it's perfectly conceivable.
Or it's just turtles.
Yeah,
all the way
turtles.
down.
But then those turtles might be made out of other things and a whole other space and whatever else. Right? It could be slugs in a grid who each have 30 neurons in some simple pattern of communicating. Yeah. There's no sense of where the bottom is.
And I think this is really interesting. Like so I was asking you the other day about the fundamental forces, right?
Mm.
We can't actually describe what causes the fundamental forces. We just describe the fundamental forces. It's kind of like they're supernatural entities, right? We can't study them directly. We can only study what they do.
Well, what causes the fundamental forces? Like, what was interesting to me about that conversation we had is that it's only weird because of the fact that you're signaling out the forces for that treatment, because it's a statement that's equally true of literally everything.
Yeah.
So it's like, yes, it's true of the forces, but it's not like uniquely true of the forces, Right. Like, it's not like we have any better explanation for why electrons exist.
Yeah, so fundamental particles are also...
Yeah.
We can't describe what causes them. We can only describe what they do.
Yeah. And there are some inklings of what sorts of things might cause them. There are like microphysical systems in like solid state physics that give rise to these things. Like, you'll see a lot of popular science articles about quasiparticles, whereas they usually forget to mention in the headline that it's a quasi-particle, like a pseudo-particle in a solid physics setup, because it's good clickbait for people to say, physicists discover new particle, and everyone clicks on it being like, oh, it's another Higgs boson. And then actually what it is, it's that in like crystal systems or whatever, lots of electrons will act in aggregate to produce this broad scale fluctuation that acts exactly like a fundamental particle field, except that
Okay. So phonons, is that?
Yeah. So phonons, spin waves. You'll see a lot of these different things. Anyons. If you go on the Wikipedia page for quasi-particle, there's like a whole bunch of different possibilities for one, but that depend on the underlying mechanics of the solid state physics system. But
aren't all particles quasi-particles?
No one knows, right? Skyrmions is another one. The interesting thing is that generically, the kinds of quasi-particles that you would get in a system that has broadly the symmetries of our universe would be the particles that we have in our universe. Like, out of any really low scale theory, there's an exception on that. Chiral fermions are really hard to generate out of a solid state physics system. cl- but it's kind of, we find ourselves in kind of a generic low energy limit of lots of different possibilities. It's like if you only had access to a sound spectrum and someone asks you what's the gas ratio makeup of the room in which these sounds were recorded, right? It could be literally anything. It doesn't, we're the vibrations. We don't have access to that underlying level of mechanics. They all produce the same sorts of laws of physics. So yeah.
So yeah, it's just it's so fascinating. You get to the bottom, and it's just a question mark.
Yeah.
We
And
don't
then
know.
the interesting thing with information, like with the question of information, because like there is a lot of, it seems like the universe has a lot of information in it, right? Like depending on how you, well, yeah, but it's unclear because like the question is, where does all that information originate?
Yeah.
And I don't know, one of my favorite ideas is, well, like there are lots of systems that can take a very small amount of information and a very simple set of rules and turn it into something that looks like it's a vast amount of information. Like I don't know, cellular automata are an example of this, right? Like you give it one little white square and it, put it through, the rules for Rule 31 or Conway's Game of Life or whatever, and it grows something crazy. Fractals like Mandelbrot sets are another example of this. But even then, I'm not super, I don't know, even in that case, you do start with a lot of information because you have a bunch of other cells that are all, like in Conway's Game of Life, you start with a lot of cells that are dead. And you have to have that. And even that is information about the system, that you have this potentially infinite grid with dead squares and a few alive ones. And so, like, that question of, I don't think Conway's Game of Life is an information conserving system the way quantum mechanics is. But that question of, like, if you have a starting point of the universe, according to quantum mechanics, you have to have all the information in it from the word go.
Yeah.
How you generate that is there has to be some sort of like informational bootstrap to get it from something simpler, or you just have to sort of posit it as like brute facts, right? There is this information. It's just facts about the universe, and you don't get to ask why the information is that way instead of other ways.
Oh, that brings me to another question I had. Have you looked at? I think maybe you mentioned you looked at this before and it was garbage, but Eric Weinstein,
yeah. So his new like his sort of new physics theory that he's.
Yeah, I think he put it on display at MIT or something like 10 years ago.
He did a lecture quite a long time. I think it was somewhere in Europe. He did the lecture, but Oxford or something like that. And then he, I don't know, it wasn't super, I don't know how it was received there. I think it was received as people said, we don't really understand what you're trying to do here. We're going to wait for you to publish a paper. And he like never published a paper. Yeah. And then and then he sort of rose to prominence again through the like totally different channels on the internet. Right. And now is, has decided to put this out on a YouTube video. Yeah. I attempted to watch that video. Mm-hmm. It's clear to me that he really does understand like the math of like Lie algebras and differential geometry like very well, like far better than I do. Yeah. So he's not a kook in terms of like his mathematical abilities, but whether or not his theories are correct or like even whether or not they're sensible, it's like to me, and this seems to be broadly how it's treated in the physics community by and large, like right now, is that people look at it basically the way, do you remember that thing with the ABC conjecture in the math community? There was this I can't remember his name, this Japanese mathematician. There's this thing called the ABC conjecture in math, which is like it's like Fermat's last theorem, but more.
Okay. Yeah.
It implies Fermat's last theorem, but like a whole bunch of other things as well. And this mathematician sort of went dark for years, and then came out with this like 500-page proof of the ABC conjecture, where he developed this entire mathematics that nobody had ever heard of, and it's just so dense with like definitions and like weirdness that like nobody can check it, and he's kind of bad at communicating, and so people sometimes will try to do these like workshops to get a handle on what his ideas are and what what he's talking about, but because
it's a big investment. It's a big investment in someone, because if you're not sure if their idea is crap, because they could just be an idiot.
Yeah, and the reason why people are doing it with him is that he has a history of like really deep proofs and like checkable work. And Weinstein is like that without the credibility within the physics community.
Yeah, that's what I'm seeing with him.
Yeah.
Because it's no it's not. This is not like people being angry at the scientific community when they say that if you have a crazy idea, like, and you present it, it's not going to get traction until the people in charge are dead. Like that's really is how science tends to work.
No, that's true. But the only real way to get around that is to do the legwork so well yourself,
right,
that it's really unavoidable, the conclusion that you've come to, right?
Right.
Like you've got to you've not just got to have a brilliant idea. You've got to be a brilliant advocate, or have a brilliant advocate for your idea. In your corner. Otherwise, your idea will get rediscovered by someone else 75 years later. And someone will put a footnote in a textbook 150 years later saying, actually, this thing that we named after the second guy was discovered by the first guy, but nobody recognized it at the time. Right. So I have a feeling that if Eric Weinstein is right, that's what's going to happen to him unless he gets a good translator.
Yeah, I'm seeing him like he's saying that everyone's against him and that he's being super toxic. Like the way that he's talking, it's clear that in order to understand what he's saying, you have to dedicate some serious energy to it.
Yeah.
And it's also clear that the way he's trying to talk about himself and how smart he is and how dumb everybody is for rejecting him, it's like, dude, that's not gonna work. Like you need to find a different way to communicate this.
No. Yeah, and it's I mean, there are plenty of examples of people who have been totally shafted by the scientific world because of this, because they like either by prejudice or by them just not deciding not to publish it, or publishing it poorly, or
I know that happens all the time.
For sure. And Eric Weinstein might be one of those people, but like the amount of people who might be those people versus the amount of brain power people have to like check their work it's not worth it for any individual person, right? So that person has to, like, for better or for worse, they have to make their idea understandable to people before it can really even be checked.
Right.
So
we see this problem is super common. I think oh man, I'm forgetting the name of it's the proteins that cause mad cow disease. Prions.
Prions, yeah. Prion disease.
Prions, it seems like prions were one of those things where it took forever for it to get accepted. Endosymbiosis as the origin of the mitochondria was another one that took forever to get accepted.
How long did that take? That one?
Lynn Margulis is the one who finally popularized it, but she was working on people's work that had already died.
Oh, she wasn't actually the originator.
No, okay. I don't want to take credit away from her. It seems like she really pulled a bunch of people's work together into one thing, and she made it understandable. I mean, that's really what she did. Is she took a bunch of other people's work, put it together where they didn't see the links, and then publish it in a way that's super easy to understand, and then fought for it. Like, she would go to debates. And
that's what Einstein did. All of Einstein's famous 1905 papers are pretty much that. It's Einstein seeing, like, it's everybody just barely being able to grasp their own subfield, and Einstein going, your thing is connected to your thing is connected to your thing. Bam. right? Like
Yeah.
all these connections are made. And then, he went further and made general relativity, whatever. But I mean, that's real. That's not stealing credit from other people. That's,
Right.
having the broad scope to understand what everybody else could only see in like little fragments.
Yeah, I mean, some of the work too was tainted because of the people that were doing it. There was one of the guy who did most work on endosymbiosis before her he was a pedophile, and he committed suicide when he got caught, and like super dramatic. Nobody wanted to touch his work. Nobody wanted to read his papers because he's a sicko. But like, so yeah, there's some weird things going on there. But she pulled it all together, and she fought for it. And now it's standard. Like there is still a tiny little bit of room for debate saying that the mitochondria actually came from the nucleus, but the mitochondrial genome came from the nucleus originally. But that's pretty much like the people who still believe that. You kind of got to wonder if they just hated her personally,
right?
Because she was pretty tenacious.
Well, she's also a little like she seems a little kooky to me.
Yeah, oh yeah, she definitely is.
Like, do you? What's your take on her like Gaia theory stuff? Like, is there any sense in which that's like saying something deep and worth pursuing?
Well, I mean, I think the importance of when we study major evolutionary transitions, she's trying to say that the ecosystem is an organism.
Okay.
So the whole planet is an organism. We wouldn't want to call it a superorganism like we call a cell a superorganism, where all of its genes combine and symbiotically to form the cell as a superorganism, or we are multi-celled organisms, so we are a superorganism consisting of our own cells.
Right. We're not a like the environment or like the overall ecology of the planet is certainly not an organism in terms of it's like split up functions and is working in consort to replicate itself.
Right. Yeah. It's not trying to replicate itself. I mean,
we are.
Maybe
we could be its brain, and we're replicating it to Mars eventually. But
yeah. So eventually we could get something that's important for these major transitions. Well, something that we think is important for these major transitions of individuality. So you go from a bunch of organisms that are kind of cooperating to really cooperating, and then to a super organism. These transitions, we think what's necessary is they're competing with other superorganisms for survival and reproduction, and that top-down selection drives them to cooperate with each other to an extremely high degree, which we don't have with the entire ecosystem. Like there's not that extreme cooperation, but
competition isn't required for selection. I mean, it's an element of it, but there are plenty of other methods of selection.
Well, it really does come down to competition. It's not usually super direct, but like you are in competition to leave more offspring than everybody else who's trying to leave more offspring, because there really is a limited amount of resources.
Yeah. Like maybe, I don't know, what about taking it a level down? So like maybe the overall Earth as an organism is too much, but say like a given ecosystem, like the rainforest or something, that is potentially in competition with a desert ecosystem or a grassland ecosystem or whatever. Like, is there any sense in which you can talk about those competing with each other? Because, the better the rainforest does, the more space it takes up and, replicates itself and whatever.
Maybe. I mean, because you can get the rainforest butting up against a desert and then taking it over, right?
Yeah.
I don't know. It gets weird, and there's a lot of stuff that still needs to be figured out with how natural selection works with groups, and people are trying to figure it out. So you might hear these debates between group selection versus
I have definitely heard those debates.
Yeah. Those are consistent, and those are persistent because there's really something to be figured out there that's not quite figured out with current models. I think maybe it's just people are idiots and they're arguing about something that should have been settled a long time ago, but I doubt it because there's a lot of smart people in both areas.
Well, it's. I mean, one of the problems that I can see in it is that the definitions are inherently kind of blurry. Like, if your organism is in fact a group, then you're talking about like it, and your gene is your genome is in fact a group of genes and all this. Like, you really have to either go all the way down to like the I don't know, is it the Dawkins thing? Like everything is just the individual genes that are the replicators and nothing else is selected for.
That's
That
how
kind
he's
of battle?
interpreted, but that's how some people in the group selectionist community will say. That's what they'll say he's saying, but it's not what he's saying.
Right. Okay.
So a lot of the debates between these groups comes from them being angry at each other and misinterpreting each other's work,
Okay.
and not giving
Lovely.
it not giving it the respect that it deserves to really think through it and see how it works. But so there definitely is that, and I can see that when I just when I talk to someone on one side or the other side, I can see that they're missing the other people's points. They're talking past each other. That's definitely happening. But there are a lot of people in those fields that have figured that out, and they are working with each other's ideas seriously. So Stuart West at Oxford, for example, he comes from the classic kind of gene selection foundation that you typically have when you're from England. Like that's kind of where that took hold. But he's noted several times, well, you can actually do the math. The math actually works out both ways if you do this and this and this, if you consider this and this. He's seeing that in some circumstances, you're just looking at the same picture from a different angle.
Yeah, like in I don't know, in truth, there are atoms in the void, or quantum fields and information, and you can apply different pictures to them.
Right.
Like, I don't know. It seems plausible to me that you could, I don't know, you could define group selection such that it exists, and also define it in such a way that it doesn't exist.
So one thing with the Gaia concept that's really interesting is that like there's a lot of there's these feedbacks when you look at an ecology. There are these feedback loops that stop catastrophes from happening. So if I get what can I say? So it's like, let's say that we kill all we've seen this lots of times with humans. They cause the extinction of some organism, and something else will then take up that niche and keep providing the service that other organisms in that community are feeding on or using.
Right.
They'll end up providing that service as one of their waste products instead. So, for example, in the savannah in Africa, you had elephants and wild herds that were fertilizing grasslands and tilling the soil with their hooves. Well, we can actually mimic that with cattle now. We have to do it specifically. We have to make those cattle act as though they were being scared by predators all the time. So you can mimic this by putting them in small fences and move those fences, because herd animals will bunch up when there's a predator, and that makes sure that the ground gets fertilized and tilled with their hooves really well, and not overgrazed, because they actually defecate and urinate on their food too fast to eat it all. So they move before they've gotten to the roots, so they don't kill the grass when they're in these tight herds.
Right. And you can imagine that itself is a feedback, right? Like if you have a species that overgrazes, then it kills its environment, and maybe it doesn't do so well.
Yeah. There's a bunch of these really weird feedback loops that happen, and so it kind of makes sense to talk about. I think the big problem with the Gaia concept is that it's been taken over by pseudoscience people so much. I mean, Lynn Margulis was a little bit out there with stuff. Like she got this paper published. It was about caterpillars and butterflies being two different species that like merged somehow, which is just
I've heard of this theory, but it's
completely ridiculous.
Does seem a little out there.
He was an advocate for that.
Given that, were they trying to say that about all, like, presumably not just caterpillars and butterflies, but like the entire process of metamorphosis between between grubs and
All
adult insects.
we go through metamorphosis.
Yeah.
Yeah.
They were trying to say specifically that like there were such things as grubs and such things as insects, and then they fused somehow and became one that turns into the other.
Yeah, and it's so crazy because we understand how embryology works fairly well, not perfectly, but like we definitely our current understanding is way beyond trying to think things like that. Like, so she had this like maverick success, right? She was the underdog who came out. She was a woman, which it was hard to be considered. It like, I mean, still is like women still struggle in science. As progressive as we like to think that we are, women are still struggling. If you talk to them, some of them don't like to talk about it a whole lot, but people will tell you, yeah, it's hard to get respect. So she had that going against her. She had this idea that it kept being rejected that she was trying to promote, and she succeeded. And I think she kind of took on this
champion of the underdog theory kind of thing.
Right.
Yeah.
Right. So she would find weird ideas like this and promote them. And so I don't know how much she actually believed in them, though. It's like she was trying to give people a fair shot. She would probably be there with Eric.
Yeah, I've noted like
promote his.
That's what I feel like this entire like intellectual dark web thing that Eric Weinstein is part of. They kind of have that thing, right? Like, I think all of them have some experience of being either real or perceived marginalization within academia, right? Like Brett Weinstein's got his whole story about his telomere discovery and whatever else, and
right.
And then not to mention his whole thing at Evergreen State and all that. So like now I think they kind of have this collective meme within them of like there are a lot of good ideas that aren't getting play, and our job is to find all those ideas, and because of that, they have a tendency to be uncritical of ideas if they're
mainstream.
If they're sufficiently underdoggy, right?
Right.
It's like we've got to give this its fair shot, so we're not really like we're just gonna kind of adopt it and like push it as far as it goes, instead of being like, well, maybe there's a really good reason why 99% of these ideas haven't been adopted. Like. There's a selection effect to Diamond in the Rough stories where you hear about all the rocks that actually turned out to be diamonds.
Yeah.
So, I don't know.
Yeah, it's a good thing though. Like you
need those characters in academia, right? To find the diamonds, but you shouldn't rely on them to always find diamonds. They'll probably find one or two.
Right. Yeah. And that's what that if you look at Lynn Margulis's work, her like a lot of what she said was just totally wrong, but the endosymbiosis of mitochondria was dead on like that. And it was super important. Yeah. Understanding that is super important. So, I think you don't want a monoculture in science. Well, if you care about scientific progress, you don't want a monoculture. If you want things to be stale, which maybe I actually go back and forth on this, like whether or not I care about scientific progress in general or just the public understanding of science, because I feel like we're discovering things so fast that we're going to run off a cliff here pretty soon.
I mean, I like scientific progress when it likes me.
Yeah.
I want COVID research to go real fast. That'd be nice.
Yeah.
Lots of new discoveries. It will be interesting to see where, like, in my hierarchy of things that I am trying to promote in my own work, I think, like, public understanding of things that are already discovered is probably at the top. Yeah. And then below that is furthering our own scientific understanding, because I think that's really cool, but I'm also afraid of some of the consequences because of great powers and great responsibilities and stuff. And then at the very bottom of the totem pole is encouraging people to themselves stay in academia and become research scientists. I think, I don't know, people have different focuses on that, but I find that institutions have a tendency to think that I'm doing the third one, where in fact I'm trying to do the first one.
That's the same with me too. It's like, I actually I might have made a high school teacher upset the other day, because I was talking to her class and I was saying, they asked me like how what schooling that I went to get to where I am, teaching biology on the internet,
Mm.
like as a full-time job. I was like, well, actually, everything I learned was outside of school.
Yeah.
And what I said to them, I recommend that you follow your interests and just follow them as far as you can, and don't worry about having to do that inside of an academic setting. Just follow your interests, because I make my living on YouTube. YouTube did not exist when I was in high school. It didn't exist for part of the time when I was in college. So like you can't expect the school to prepare you for your career. It's just teaching you how to teach that, or
Yeah.
teaching you how to
I mean,
learn.
especially when the career landscape is accelerating and the school landscape has an incentive to pretty much stay the same.
Yeah.
I don't know.
Well, it's just hard. Like, and literally the jobs that are going to be available in the future, you don't know exist. I mean, who knows? It might be like bounty hunting and
Yeah.
zombie killing. I don't know.
Could be. But our jobs weren't jobs when we were in high school.
Right.
Right.
Yeah.
Um,
So, yeah. I mean, yeah, we both created really weird jobs for ourselves too.
yeah, a little bit. Alice has a good. I mean, we're running over time. Do you mind? Does the chat mind? We also haven't been very I don't know, interactive with the chat. They've been having some pretty I don't know, heavy philosophical conversations and like life conversations in there. I appreciate you guys for hanging out with each other while we're hanging out here, but it's hard to. I don't want to be too ADHD with it. But Alice was saying, because Alice works with Derek from Veritasium, and she just put this comment. One of my profs said Veritasium is essentially brain candy, and it's not. And I think about that sometimes. I wonder about that for myself, like whether I don't know. We might have talked about this before in person, but like whether or not I'm taking people down a path that's going to lead to their self-sufficiency in terms of how they learn things that I haven't taught them.
Yeah.
Right. And whether we as YouTubers as a whole are doing that properly. Like, and it sort of came from, it's an idea that came from an anecdote of a friend of mine. And it's like, he's one person, so n equals 1. It's not a great sample size. It's not like data, but it's like, it presented it to me as a possibility, because it's a friend of mine who's like really wants to be a scientist and has watched like all of science YouTube, like every all the Veritasium videos, all like the Minute Earth and Metaphysics and whatever else videos, and couldn't like and sort of left his degree because he couldn't make him, like, he's probably pretty ADHD like I am, and like couldn't make himself understand the concepts and actually like do the research like that requires that's required to get a degree. And it spooked me a little bit, right? Because I can feel my like ability to do research decrease the more that I consume online media. Like sort of my like intentional sit down and really focus on something for hours and like work it out pencil and paper and like have the drive to do that. Like, and and I mostly consume informational content on the internet. It's not like I'm mostly watching things, the classic like brain rotting whatever like stuff. We're really good at packaging the stuff that especially gets popular and goes viral is really, really good at packaging the specific things that can be really well packaged, right? And then you kind of, if you look beyond that, all of a sudden you run into a wall where not only have you've learned all the things that were easy to package, and now you run headfirst into all the stuff that even the YouTubers couldn't figure out how to make sense of in layman's terms. And it's like a real quantum leap into difficulty out of that. And I don't know. I don't want to send people down a garden path of thinking this is like that learning from scientific research papers is going to be like learning from YouTube videos.
Well, I feel like one of the things that people get from these videos in general is that things can be figured out through careful study and reason. And I think what you're exposed to, even with Veritasium, if you want to call that brain candy, is that
like I don't think by any means Derek's work is more brain candy than my work. I would say definitely we're both a little more brain candy than, say, I don't know, Grant Sanderson is, but still, like, it's, you know, it's high quality scientific, like, educational work, right? Like for the purposes of increasing the understanding of science in the population, I think it's 100% fantastic. But
yeah, but also I think that what okay, so what I've gotten from your videos is I've gotten questions that I never thought to ask. Like you're talking about the arrow of time, and
Yeah.
I remember I spent a long time thinking about that after watching that song. And
Nice.
it's now something that every
Cool.
time I hear someone talking about time and how it moves, I'm curious as to how they're going to describe it, because I still don't fully. I mean, it's still like one of these weird mysteries, right? Like, but I'm now interested in that, and I probably will be forever, right?
Yeah.
Until I get Alzheimer's or get
Well,
hit by a bus.
And the arrow of time is very wrapped up with these information questions. It's pretty much the same question. That's about not why is there information, but why did the information start out organized?
Right.
Is essentially the question, right?
Yeah.
Until you solve that first problem of why is the information there in the first place, I don't know if the question of why is the information organized can be answered. I don't know which one goes first there, but
yeah. So for me, what I get from these YouTubers is stuff to question about and think about and digest later. So I'm not expecting to get an education from YouTubers. And not only that, but I have no intent on becoming a full-time researcher in the future. Like I don't even consider that project to be entertaining.
yeah. But you also very clearly have not lost your ability to read dense scientific papers. It seems that you do that fairly constantly.
Yeah, and but that comes from me being frustrated with, like, so all of my learning comes from me being frustrated with something. Like I can't figure out this one stupid thing. And so I get angry and I read 1,000 papers, or someone's asked me this question, I can't figure it out, or someone's doing this anti-evolution claim. And I realize that, okay, there's something about what you said that seems wrong, but I need to consider this honestly first. Let's dive in. So, yeah, I actually spent a lot of time talking with creationists because it gives me stuff to think about and stuff to study.
You get probably the exact sense of what parts of, like, evolutionary theory don't have such a nice package yet that everybody sees them as obvious. Yeah,
and so okay, a lot of times what creationists will do is they'll exploit a misunderstanding that the public has. So that'll show me what the misunderstanding is.
Okay.
If they're being successful with this, that shows me what the misunderstanding is. But sometimes they'll show me something that I don't understand. I'm like, I actually don't know how
Nice.
I would respond to that. And so that tells me that either I need to learn something, or maybe there's actually a weakness in the field or something that's not well understood in the field. And that's actually true sometimes. Like, if you look at, so Michael Behe, when he published this irreducible complexity stuff, there was a bunch of response in the scientific literature. The biggest challenge that he gave to the scientific community that really genuinely was unsolved was how protein complexes evolve.
Because he had 4 or 5 different examples of what he called irreducible complexity, right?
Yeah.
Which is things that are so, like, large-scale biological machines that are so interdependent that there's no path to evolve them from simple machines.
Yeah, there's not a clear path from A to B. Like, what was obvious, and this was obvious to Darwin. Darwin wrote about this extensively. Is that you have these zigzagging pathways where where
A
these
enables
complex
B,
things
B
evolve.
enables C, C enables D,
Yeah.
D enables E, and then at the end you've only got D and E, and you can't see where they came from.
Yeah, so Darwin talked about the evolution of the eye, for example. He explained how by just comparing the modern species today and how their eyes worked, you can actually figure out the really weird windy pathway that it took to build a camera-like eye like we have. So a bulk of that was already figured out, but he said he has chapters in there about how biologists have no clue. They never even tried to explain how protein complexes evolve.
Right.
That was actually true at the time. And that's actually sparked it made enough people angry that they looked into it, right?
Right.
So so now we have papers on how protein complexes evolve. And a lot of the stuff right now is actually it's in hindsight looking at stuff, but now we have people in the laboratory trying to actually observe it happen in real time, which is cool.
Okay.
So I don't remember why I was talking about that, but I get a lot of inspiration.
Yeah, a niche for Michael Behe's in the culture. So you like, but you do the same sort of like you were talking about talking to creationists.
Yeah, well, we started this about YouTube videos. Like,
yes.
I get this from, I'll watch something Veritasium's talking about, and I'll be curious about it, and I'll want to try and figure it out.
Right.
Just one of the things that I've learned on the internet is how important waves are. They're in freaking everything.
Yep.
Which,
from everything is waves.
My biology perspective, I wouldn't have picked up on that so much.
Hey, there's waves in biology too.
There are waves in embryological development. I think we're really we're not paying enough attention to them in biology. So so that's I think the internet stuff's great. Says a professional YouTuber.
Educational YouTuber.
To another.
At least as useful to John Perry as creationists.
Yeah.
Cool. Should we leave it? Should we leave it here? Should we head off the stream? All right, we got to do the ending song. We're gonna do the ending song. We've been changing the ending song, but I think we'll keep it classic for today. So anyway. Oh yeah, let's go. Can I turn on some reverb on my voice? Maybe I'll put on some reverb. Hello. Hey. Reverb. Hello. Put a big reverb tail on me. Oh yeah. We're gonna sing about science. Yeah, we're gonna sing about science. We're gonna sing about science. Yeah, we're gonna sing about science. We're gonna sing about science. Yeah, we're gonna sing about science. We're gonna sing about science. Yeah, we're gonna sing about science. All right, what did we sing about today? We're gonna sing about science. What did we talk about today?
Time, information theory,
information.
YouTube.
Oh dear. Okay, I think it's chat back up. I want to see what's going on in the chat. Oh yeah. Oh, you see, we got a theory about the information of the universe. Oh, it's called quantum mechanics, and that information is conserved in his. This is really on reverb. There can be ways that the information gets removed. Called wave function collapse. But I think that isn't true. We really didn't get into that even, John. All that has to do with lots of things like the many worlds interpretation. We're gonna keep that aside for the moment. Yeah. If you got information that is conserved, then you can have an information transfer. And when two different information systems converge, they can make more combinations with that information. Oh yeah, so you get a signal from a red-winged bird to another bird that sends a signal about its health and wealth and whatever else. And also the same thing happens with the ribosomes.
Sean is making on the fly. Sing about science. We're gonna sing about science. We're gonna sing about science. We're gonna sing about science. Wait, what? Okay, what else? We're gonna sing about science. Yeah, we're gonna sing about. Is the Earth a big organism called Gaia? Maybe. It seems like it's too complicated. I don't buy it. But maybe in ecology there could be some sort of way that different ecologies interact on the Serengeti versus, I don't know, like the desert or the jungle. I don't know what I'm talking about. What was Oh, I crashed and burned on that one. What else are we talking about?
Is YouTube just brain candy?
Have a good idea and you push it through to the mainstream. Sometimes your idea was obscure for a reason. Oh yeah. You get one idea that's really good. You get the next one and you think it's the same, and you keep pushing on and think of yourself as a martyr in the community. Then you got the problem of YouTube. Is it doing more harm than good? Probably not. But there are certain things that we should avoid, like pretending that this is actually how all information is transferred to your brain. We're on information again. Oh, Tipsy Tim would be a blast is what Zach S is saying. We should try that someday. Try that new informational state. Oh, we're gonna sing about science. We're gonna sing about science.
Black Plague.
Black Plague. Oh. I forgot about the plague. Let's see. What do we got? Yersinia pestis, that is the best at killing folks all over the Middle Ages. It's insane, they would all just die like flies and abandon the tribes and go on to other walls, and they wouldn't get let in. We're all afraid of them. The Black Death leading to even more expansion of the economy, but that's just a side effect. Please don't kill people just to get yourself a check. No. Oh, still, I don't know. Thanos was middling.
Exponential growth makes Thanos' thing only work temporarily. The population will immediately explode.
Unless we cut ourselves off afterwards, though. We're not gonna exponentially grow forever.
True.
You get wealthy enough, you stop growing. I don't know.
But then you'll whittle down that wealth back to where you're at in the current state.
We should have a rap battle where I don't want to take Thanos' side in a rap battle. Oh, plague! Don't get it. All right. I think we're gonna call it here.
All right,
John, thanks for coming on.
Oh, that's fun.
This is a lot easier to do when I have someone to do it with.
Yeah.
Yeah, I know. Let's people in the chat. Who are you? Let's see who we got so we can shout you out. And on Twitch we got mostly Mooks2000_ and Smith in the chat right now. 25 minutes past the hour. Yeah, that's what we did today. So let's see who we got. We got Sarah Elder, Allison Walker, Paul Jark, Zach S, Alice, Jan Hoffman, R, Joan, Vlad, KSP, Emily Urkel, the Frisian Atypical Reader, Kovu Given, Ewa Jessic, Sarah Elder, Jan Hoffman, Ann Smith, Alidilla 1, Philippa Beckman, Daniela Guerrero, Via File. We got Dragon the Water over there, Jan being in two places at once. John, what do you got? You want to tell people anything? Anything that else is going on with you?
No. Well, I drew a picture the other day.
Drew a picture?
I drew a picture of Grand Theft Auto as Grand Theft Auto characters as essential workers.
Interesting. Can you show us, or is it
Hold
not
on.
possible?
You have disabled screen sharing, so I cannot share it.
Damn. Probably because it would mess with the entirety of my streaming setup.
It is on Twitter, though.
Okay,
You can see.
go follow John Perry at Stated Clearly on Twitter.
Yes.
Follow him at youtube.com/statedclearly. You
You can see my Grand Theft Auto art day.
Are you gonna keep going with this? Make a Grand Theft Auto COVID-19 video game?
Yeah. That's it. That's it. I just want to do that. I had the idea and I had to do it, and then I'm done.
If anyone wants to take this idea and run with it, tweet at Stated Clearly, and do all the work, and John will take 50% of the profits for finding the idea.
And probably have to be Rockstar Games, right? 'Cause
I
they're
guess
the
so.
ones who invented that.
It's an homage. I don't know. Copyright. Let's.
Man.
It's the internet.
Yeah. True.
Okay. All right. Signing off. Thanks for coming on. Again.
That was fun.
And I'll talk to you.
I didn't totally finish
this
my
again.
drink.
I
but-
did. I need to get a bigger drink next time. I was done like an hour in. But
All right.
you do have a larger drink than me. So
Yes.
I forgive you. Yeah. Okay. So, thank you all of you for stopping by, and we might do a Twitch stream later tonight. We're not gonna do one immediately because I really need to go eat. So if there's gonna be a Twitch stream tonight where I start to do some production things, I will let you know on the Discord. I'll put an announcement up if I'm gonna do it, but I might just keep reading. I've got a lot to read about spin. So, have a good day, folks. I'll see you tomorrow. Yeah.
We're gonna sing about science. Oh yeah. We're gonna sing about science.
Bye, folks.